In Satbayev University, we study enhanced oil recovery technologies. For this purpose, we use this equipment. The core fluid experiments are conducted by using this high-pressure piston pump, which can inject different fluids at a constant flow rate and at up to 400 bars into this core holder. We work with such rocks. For example, this is a sandstone sample which was saturated with oil. We can displace this oil by using water, surfactant, alkali or polymer solutions and measure how much oil can be displaced by using a certain fluid. Besides enhanced oil recovery, this equipment can be used to study the interactions between drilling fluids and rock samples. For example, if a drilling fluid invades into the rock, it damages its original permeability. And by using this equipment, we can measure in how many times. Also, we can inject different fluids, for example, acids, in order to recover the original permeability of the sample. In this laboratory, we use such models in order to visualize the process of oil displacement on micro level. This model has a lot of microchannels inside, and it is placed under the microscope, and then different fluids, including oil, water, and solutions of different chemicals, are injected inside of this model. This helps us to visualize different processes which take place on the micro level and helps us to visualize interactions of different fluids inside of a porous media. The drilling fluid laboratory has a rotational viscometer. The rotational viscometer can be used to measure dynamic viscosity of a drilling mud or a cement slurry. Also, we work with such polymer gel formulations. The accuracy of this device is ensured by using the calibration fluid. This device can measure viscosities over a wide range of temperatures. The EP and lubricity tester is a high-quality instrument which is used to measure the lubricating quality of a drilling fluid. Also, this instrument provides data to evaluate the type and quantity of lubricating additives that may be required. Besides that, it may be used to predict wear rates of mechanical parts in known fluid systems. The portable roller oven is an effective instrument to determine the effects of temperature on drilling fluid as it circulates through the wellbore. Aging the drilling fluid in pressurized containers effectively demonstrates the thermal effects on viscosity and how various additives behave at elevated temperatures. Aging is done under conditions that vary from static to dynamic and from ambient to highly elevated temperatures. This device can operate at temperature as high as 230 C. The high-temperature, high-pressure filter press is designed to evaluate the filtration characteristics of drilling fluids, cement slurries, fracturing fluids, and completion fluids under elevated temperatures and pressures. The dynamic linear swell meter is designed to simultaneously test up to 4 drilling fluids on a representative shale sample for extended periods of time at temperatures up to 180 Fahrenheit. The linear swell meter is the only swell meter capable of dynamically testing fluids to obtain the most accurate data possible. TX500 spin and drop tensiometer is used to measure interfacial tension between oil and water. This has a lot of applications in the formulation of drilling fluids and chemical solutions which are used for enhanced oil recovery applications. This device is used to measure pH of different formulations and water solutions. Our laboratory also has such commonly used equipment as retor kit, mud balance, turbidity meter, and emulsion stability meter. Every laboratory should have a vacuum pump to vacuum fluid and rock samples. In our laboratory, we have this very high quality vacuum pump, which is used regularly. Every laboratory should have a high precision scales. In our laboratory, we have this, and it is used to measure small masses of chemicals in the process of preparation chemical solutions, and this is very important for the high quality of the research.